So for 70, the reference points are 1, 0, and base 1. In this case, base is 3. The a is negative 1 and the k is positive 2, so that's why the y is the one that's transformed. The x is not. So changing the points would be 1, 0, 1, 2, 0 plus 2, and then 3, 1. Okay? The vertical asymptote did not change because h is 0 in this case. Alright, so I extended the x-axis a little bit just to show you that, it's not, the x-axis is not an asymptote. The graph will cross the x-axis at some point. So 1, 2 is here, and 3, 1 is here. Okay? I'm going to calculate where it's going to cross the x-axis by making the y 0, and then solving for x. That's how you find the x-intercept. So subtract the 2, and so the negatives cancel out, so negative cancel out. So now it's log by itself. Log base 3 of x equals 2, so this means 3 squared equals x. So x is 9. So it's going to cross the x-axis at 9, 0. Okay, so we go like that, and cross. So on this one, the first thing I'm going to do is move the the coefficients up to exponents. So like this one, and this one. Okay, so I'm going to do that. Let me see, that's going to be log base b of x to the negative 2 minus log base b of y to the 6 plus log base b of z to the 1/7. Going from left to right, here, these two, it's a difference of the log, so that's going to be the log of the quotient. So that's going to be log base b of x to the negative 2 over y to the 6th. Right here, this is, I'll put it like that first. So here's the sum of two logs, so that becomes the log of the product. So log base b of x to the negative 2 over y6 times z to the 1/7. Now x to the negative 2 I'm going to bring down because the exponents should be positive for it to be simplified. So this becomes log base b of z to the 1/7 over x squared y to the 6th. And that would be the answer. So this one, the first thing I'm going to do is I'm going to apply the fourth root right here, this one, to each of the terms here, of the factors, this one, and this one. Okay, to the term. So I'm going to rewrite it as log base b of x to the 5/4 times y to the 2/4, which is 1/2, over z to the 4/4. 4 over 4 is 1, so it's just z. So now I'm going to break up this first. Actually, I'll do the quotient. The log of the quotient is actually the difference of the logs. So this is log base b of x to the 5/4 times x to the 1/2 minus log base b of z. Now I'm going to break up the log of the product, which becomes the sum of the logs. So log base b of x to the 5/4 plus log base b of x to the 1/2 minus log base b of z. And finally, to be completely expanded, those exponents have to come down. So remember, those are the coefficients of the log, so that goes here, and that one goes right here. Okay? So 5/4 log base b of x plus 1/2 log base b of x. Oops, sorry, they're not both x's, this is y. Sorry about that, y. And then minus log base b of z. And there's the answer. So for 73, first thing I'm going to do, I'm going to write it as the sum of two logs. So this becomes log base c of x to the 6th plus log base c of y to the fourth. Now the exponents come down, so it's 6 log base c of x plus 4 log base c of y. And that's as expanded as you can get it. So to condense this log, I'm going to do the brackets first. So I'm going to simplify this part first. So let me bring down the natural log of x minus, now that's the sum of two logs, so it becomes the log of the product. And so now I have the difference of two logs, so that's the log of the quotient over x plus 6 times x minus 6. So then this is natural log of x over x squared minus 36, because I multiplied the denominator. Okay. 75 we're simplifying, so this is the log of a quotient, so I could write it as the difference of the logs like this. And then the 3 comes down as the coefficient of that log, so this equals natural log of 2 minus 3 natural log of e. And we know natural log of e is 1, so 3 times 1 is 3. So you say natural log of 2 minus 3, which can be written as negative 3 plus natural log of 2. Now we have to use a change of base theorem for this one. So you could either write it as log 6 over log 1/3, or you can write it as natural log of 6 over natural log of 1/3. Either one is fine. Oops, 1/3. And when you plug this into the calculator, you get negative 1.631. So first thing we're going to do is divide by 2. So I get 5 to the 2 minus x equals 6. Now this is different from the other ones, the first ones that we solved exponentials on, because we're not able to get the same base on both sides. So we have to use logs. Okay. So I've got the base by itself, the 5, so it's going to be log base 5 of 6 equals the exponent. So I'm going to, I guess I can subtract the 2. So negative 2 plus log base 5 of 6 equals negative x, and then change the sign, multiply by negative 1. So x equals 2 minus log base 5 of 6. So to put this into the calculator, you have to change the base, use the change of base. So natural log of 6 over natural log of 5 like that, or you could choose log over log, that's okay. So you put this into the calculator and you get x is approximately equal to 0.887. Alright, so we're going to add 22. So that's going to give you 4e to the x equals 35. We're going to divide by 4. So that's e to the x is 35 over 4. And then for that, natural log of 35 over 4 equals x. So you just punch this into the calculator, natural log of 35 over 4, or change it to a decimal, it's okay, either way. You get x is 2.169 when you round it to 3 decimal places. So we subtract 9. And so 2 natural log of x equals negative 5. Divide by 2. So natural log of x equals negative 2.5. So e to the negative 2.5 equals x. So that's going to give you, when you punch it into the calculator, approximately 0.082. Alright, so here's the equation for number 80, and for A they want to know what's the population at time t equals 3. So you just replace the t with the 3. Like that, and then simplify the exponent so that when you multiply the 3 times 0.052, you get 1600 e to the 0.156. Put this into your calculator and you get 1870. So for B, they want to know after how much time will you have 10,000 bacteria. So we divide by 1600 first because we want to isolate the base. So by 1600, oops, not working, right there. And so that gives you, let's see, divide by 100, like that. And you could divide by 4, so 25 over 4 equals e to the 0.052 t. And so natural log of 25 over 4, you could change it to a decimal if you like, equals 0.052 t. We're going to divide by this because we want to leave t by itself, right? So you put natural log of 25 over 4 divided by 0.052 and you get 35.2, and the unit is hours in this problem. We want to know how long it's going to take to double the investment. So remember, whatever p is, we're going to double it. So we end up with 2 equals e, and the rate at this problem is 4%. So it doesn't even matter what we started with because all they want to know is how long will it take to double your money. Okay, so natural log of 2 equals 0.04t. We're going to divide by 0.04. And so that gives you the time is approximately 17.3 years when you plug that into the calculator. So this time they tell you that the money doubles in 6.3 years, and they want to know their interest rate. So again, it doesn't really matter what you started with. I know they told you 5,000, but it doesn't matter. We doubled it, and the time was 6 years. So natural log of 2 equals 6r, divide by 6. So r is, you get 0.11 and it goes on, so what you get is 11%, because you have to move the decimal 2 places to the right.